In the previous video, we have discussed about the complementary number system. So let us talk about why we are discussing it, means what are the advantages of using the complementary systems. As I have told in the previous video that if we want to perform the subtraction with the only adder circuit, then we have to use the complementary number systems. Now the problem is how a particular adder circuit can be used for subtraction. So in this video we shall talk about all these things. I mean, how the addition can be used as a tool of subtraction. Now let us assume, suppose you are subtracting two numbers, n1 minus n2, right? n1 is a particular number and n2 is also a number. So what does it mean? This symbol indicates subtraction, right? This is nothing but subtraction. This operation can be done in a different way also. Suppose if I add the negative of n2, then we will get the same result, right? What I have done, in place of subtraction, means in place of minus sign I have put a plus sign, and in place of n2 I have written minus n2. Now this minus n2 is called the additive inverse of the n2. What do you mean by additive inverse? Suppose a is a number, if I add something with it, suppose if I am adding x with it, and then if I get 0, then x is called the additive inverse of a and vice versa. That means a is also called the additive inverse of x, which is nothing but the negation of the number, right? So here we are adding the additive inverse of n2 with n1 to get the n1 minus n2. This is the basis of subtraction. This is the basis of subtraction method that I have discussed in the previous video using the adder circuit only. Now, how can I obtain the additive inverse? To perform the subtraction using the adder circuit, we need the additive inverse first, right? Now, how can you get that? To get this value from n2, we need the complementary number system, right? So in the previous video, I have told you that we have two types of complementary number system. One is diminished radix complement, right? Diminished radix complement, and another one is radix complement. Right? Now diminished radix means nothing but base minus 1's complement, and this is the base's complement. To obtain diminished radix complement, we have the formula, I think you remember, b to the power n minus 1 minus x, right? Where x is an n-digit number and b is your base, right? In the base of the number system in which you are working. Now, so what we have seen, to perform the subtraction we need the additive inverse of a number, right? So okay, let's see. Suppose we are trying to perform this operation a minus b. So what we can do, a plus minus b, right? Now to obtain minus b, we have to find out so minus b is nothing but the additive inverse of b. So minus b can be obtained using the complementary number system. So what we have seen earlier, that x complement, that means in case of basis complement, it is denoted as x bar. It is nothing but b to the power n minus 1 minus x, right? This is the complement of x. Now if x bar is considered to be the additive inverse, then what should we get? If I add x and x bar, then we should get 0, right? Why? Because if a particular number is the additive inverse of it, then we should get 0 when we are adding that additive inverse with the original number. I hope you are getting it. Suppose x is a number and y is the additive inverse of it, then if you add x and y, then you should get 0. That is why that number is called additive inverse, and vice versa. Means x is the additive inverse of y and y is the additive inverse of x. Clear? Now, so this thing should be happen. If x bar is the additive inverse, now if I expand it, what should we get? X plus b to the power n minus 1, right, minus x. So x will be cancelled out. What is remaining? B to the power n minus 1. So this is nothing but the largest possible number in the base b with n digits, right? For example, if you have 2 to the power 3 minus 1, this is nothing but 3 ones. So this is the largest number in the base b, that is in the base 2 with 3 digits. Here what is the largest digit in base 2? 1. So if you repeat ones 3 times, then you will get the largest number, right? So this term is nothing but the largest number in base b with n digits. Now according to this thing, this should be 0, right? But you know this is not 0. Then what is the problem? See, in the diminished radix complement, we have two representations for 0. One is all zeros and second one is the all ones in case of binary system, or all f's in case of hexadecimal system. For example, if you consider the binary system, suppose we are considering the binary system, then we have two representations for 0, this one and this one in case of 4 digits. If you are using octal system, then we have two representations of 0, right? In case of hexadecimal system, we have two representations, and similarly in case of decimal systems, we have two representations. This is one of the problem of your diminished radix complement. To represent 0, we are using two representations. So what are those representations? One is all zeros and one is the largest number possible in that base, right? So otherwise, if you do not represent this pattern as 0, then the total system will not work. We are assuming that the x, this one is as your additive inverse of x. Now if you add it with x, you must get a 0. If you do not make this pattern as 0, then the total system will fail, right? Why? Because if you add it with the original number, you will never get 0. So we need two representations of 0 here. So this is one of the problem of diminished radix complement. Now let us talk about the radix complement. I hope you have understood it. If you have any doubts, please rewind the video and again listen it. Right? It is very easy. We are just talking about the additive inverse of this number. Why we are talking about additive inverse? Because we want to add that particular value with the another number so that we can perform the subtraction. Now to find out the additive inverse, we are performing the complement operation. In case of diminished radix complement, this is your formula. So we are considering it as an additive inverse. Now when you are adding with it, then you should get 0. Then when you are simplifying it, then we are getting this value which is mapped to 0. The value is not 0, but we are mapping this value to 0. Why? To satisfy this constraint. I mean, if you do not map this value to 0, then the total system will never work, right? Now let us talk about the radix complement. So in case of radix complement, if you see, the formula is b to the power n minus x, right? Now if I consider it as the additive inverse of x, so this is the nothing but x complement, right? In case of radix complement, if you consider x bar as the additive inverse of x, then you should get x plus x bar equal to 0, which is nothing but x plus b to the power n minus x equal to 0. Now x will be cancelled out, b to the power n equal to 0. Now you may say that this value is again not 0, right? What is the meaning of b to the power n? If you are using in binary system, If you are using binary system, then what is B? 2, right? If you are using suppose 3 digits, then what will be the value? 2 to the power 3 is nothing but 8, is nothing but 1,000,000, right? For example, again, if you are using 5 digits, then 1, then 5 zeros. Clear? Similarly, in case of decimal, what will be the value of it? Suppose you are using 2 digits, then 10 square, right? This is nothing but 1,000,000. Clear? Suppose you are using 5 digits, then nothing but it is 1 5 zeros, right? Similarly, in case of octal system, if you are computing it, so what is the base? 8, 8 to the power 3, it is nothing but 1,000,000. You can compute it. Suppose you are using 2 digits, then it is nothing but 64, right? It is nothing but 1,000,000 in octal. Got it? So what do you mean by b to the power n? The 1 at first 1, then we have n zeros, right? N number of zeros, n zeros. Now you can see that this total value is not 0 again, but we are talking about only n digits. That means if you are performing a mathematical operation and if you have only n registers, then what will happen? When we are getting this number, then for these n numbers will be stored and this one will get discarded. I don't know whether you have understood it or not. Again, suppose we are storing this number in a particular register, then what will happen? We will store these n zeros because we have only n registers. Now the remaining digit will be discarded. So what we will get? We will get effectively 0. Got it? So in every base, see, suppose we are dealing with 5 digits, then 3 to 5, we will store only these 5. Got it? Why? Because we are dealing with 5 digits, we are computing in 5 digit registers, or you may say the original numbers are of 5 digits. So we are concentrating on only 5 digits in this case. In this case, we are only concentrating on 3 digits. That means we have to store only these 3 bits. Clear? So in case of radix complement, as you have seen, the representation for 0 is 0. So we have only one representation for 0. This is the advantage of radix complement, whereas in case of diminished radix complement, we have two representations for 0. One is all zeros in n bits or n digits, and another one is the largest possible number with n digits in that particular base. And in case of radix complement, we have only one representation, that is nothing but all zeros. So this value, when you are complementing it, this complement can be used as the additive inverse, right? In case of diminished radix complement as well as in the radix complement, this complement value can be used as the additive inverse of x, so that we can perform, suppose you are performing x minus y again. So if you find out the additive inverse of y, so what will be the value? Minus y, right? Now this negation is being done by your complement. So if you add complement of the number with the first number, then you should get the subtraction, means you should get the result of subtraction operation, right? So why we are studying this complementary number system? To perform the subtraction operation using an adder. How we are achieving it? We are trying to find out the additive inverse of a particular number, so that we can add that number with another number and we can get the result of the subtraction using the adder circuit only, right? I hope you have understood it. If not, please rewind the video again. It will be very clear. It's a very simple topic, right? The basis is we are considering the complement as the additive inverse, so that we can add the complement with the original number and we can get the result of the subtraction, right? in the diminished radix complement we have two representation for 0, and in case of radix complement we have only one representation for 0, which is the advantage for the radix complement, right? So this is all about your basic theory. In the next video we shall discuss how the subtraction is being performed with some examples. Then it will be clear, it will be more clear, I think. Okay, so this is enough for this video. Okay.